right, so in this lesson we're going to use right angles. Essentially we're just going to use it in angles of elevation and depression. So yeah, we're just going to get straight to it and see how we go. So yeah, use right angle triangles and Pythagoras. In actual fact, there's no Pythagoras in this, but we've got to know Pythagoras in this topic. If you don't know it, we've got to look back to year 8 and see how we go. Okay, so here's the question. All right, angles of elevation and depression. So Sam is hang gliding in Newcastle, 75 metres above the water. So let's draw this. This is the water, and so Sam will be here. Okay, and he's hang gliding. All right, so there's a hang glide. There he is. And that is 75. So that's 75 meters above the water. Okay. Now the beach is right here. It says the beach is seen, and it's seen with an angle of elevation, with an angle of depression, because we have to go, depression is down. If I feel depressed, I feel down, okay? So the angle of depression is 15 degrees. If I can actually write 15 degrees, I'm actually going to change colours. 15 degrees, okay? So now there's two questions. It goes, how far is Sam from the beach? Now one of them is line of sight. So the line of sight is this one, okay? Because that's where you can see the beach, it goes, and the other one is measured along the water. Okay, so let's do line of sight first, okay? Now, what happens here is that we've actually got a right angle triangle. One here and one here, if we actually draw this triangle up. So whichever you use, it will work the same way. I'm just going to use this one that I've just drawn there. So I'm going to put some information. So this is 75 meters. It's the same as this one. Okay. I've got the angle there, and now I can find. So I'm going to find the line of sight. I'm going to call this X. Okay. So I want to. Well, I don't know why I got the angle there. I need to find X because that's the line of sight to the beach. Okay. So I'm going to use old school trigonometry. I'm going to label all the sides. The sides opposite the right angle is the hypotenuse. The side opposite the angle is the opposite. Okay, and so the other one must be the adjacent. Now, which are the two sides that have information in? Well, it's this and this, so it's the hypotenuse and the opposite. So I need to find a trigonometric ratio that gives me hypotenuse and opposite. And hopefully you already know that that's sine. So it's going to be sine. And we know the angle. What is it? 15. So 15 is equal to opposite, which is 75, over hypotenuse, which is x. Okay, which I've labelled x because we're drawing this in. Okay, so we just need to find how far line of sight Sam is from the beach. So when you've got the pronumeral at the bottom, all we do is we swap these two around. So I'm going to get x equals 75 over sine 15 degrees, and I'm going to pop that in my calculator. So if I go, I'm popping it in now, 75 over, and I'm popping it as is, okay? So I get 289.777749,479, and that will continue to go on and on and on. And so I need to just summarize it a bit better. So I'm going to go, therefore, Sam line of sight distance is, and I'm going to write it, it'll be, I'm going to go 290 meters, and that I'm going to go in brackets nearest meter. So what I've done, even though the question hasn't asked me if to round it to nearest meter, you don't have to round it to nearest meter, But because I have this situation here, there's no way markers can take marks off me because I've explained myself fully. Okay, let's find how far he is measured along the water. So measured along this way. So that's going to be the same distance as this way. So I'm going to use that angle. I have to use a new pronumeral, so I'm going to call this y, this distance there, the horizontal distance, and I'm going to find it. Now, I'm not using the hypotenuse in this case. I'm still using the opposite. I'm still using the opposite and adjacent. So which trigonometric ratio am I going to use now? Hopefully you said tan, so I'm going to go tan 15 equals opposite over adjacent. The opposite in this case is 75. And the adjacent is the y, which we need to find. And we have exactly the same scenario as we've had here. So I'm going to swap these two. So I'm going to get y equals 75 over tan 15. And now I'm going to pop that into my calculator. And I get, well, let me pop it in, tan 15. And I get y equals 279.9038106, and that will continue going. Therefore, y equals 200, let's go 80 meters to the nearest meter. Okay. Now, just a couple of things before we finish up the video. These answers actually make sense because the diagonal distance down will always be longer. The hypotenuse is always the biggest than the horizontal distance. And 290 is bigger than 280. It's really important that we start thinking about our answers to think, does this answer make sense? Anyway, that's our lesson. Peace out.